Hi guys, my name is Jonathan Tengbe. Welcome to Tengbe's Learning Content again. Today I'm going to show you guys how to convert binary to decimal and then to hexadecimal and vice versa. The reason I'm doing this is because as you can see, my learning content will mostly be Cisco uh, routers configuration and switches, and then there is going to be a point where we're going to be talking about some subnetting, and I don't want you guys to get confused. That's why actually I feel like this is really necessary for me to do this for you guys. That way when we reach to that point you don't have to get confused, and this is really important. Most students get confused for this, so let's just get this down first. We nail it down, and then when we reach to our configuration we don't have to get any doubt. So without any wasting time, let's go into my little board over here. And then as you can see, I already have some few mess going around, but I'm gonna clean it up right now. And let's just do that. Sorry about that. And let's do it right here, as you can see. So as you can see, the numbers starting from 128 all the way to 1. So these are the numbers that are really important to us if we really want to go into converting binary numbers to decimal and then decimal to binary. This is our table we have to consider, because in most points, some people have already told me it's really difficult because they tell them you have to memorize the numbers, and there is no point for us doing that. That is a lot of too much information. That is information overload. So there is no point of you doing that. So basically, as you can see, if you add all those numbers together, if you are with me, if you add them all together, you will get 255, which is basically, this is one of the numbers you'll be using for our subnet or subnetting. And this is basically very important. We have to remember these numbers. So all these numbers, if you add them together, you will get 255. So this is going to be our subnet max. Like as times goes on, not for this video, forget about the subnet max for this video. This is basically just converting binary to decimal and then decimal to binary. This is all we are here for. So without wasting time, let's just take a random number. Let's just start with 1 0 0 1 0 1 0 0. So as you can see, we already have a binary number, so there is no way we can know. We have to find a way to convert this number for us to know what kind of numbers the computers want to use. So basically what we do in this number is starting from 128 all the way to 1. If you see a 1 under 128 through to 1, that means that number is the only one we are going to consider. The numbers that have 0, they are off. Don't worry about them. Just go ahead and add up the numbers that have 1 underneath. That's all we need. So the numbers that have 1 underneath, we have 128 over here, and then plus, because we are adding them, and then we have 16 1 underneath, and then of course we have 4 have 1 underneath, and then the rest of the two last two doesn't have any 1, so that means they are off. We don't need to consider them. So what we do, we add these three numbers together for us to get our decimal number. So we do 128 plus 16 plus 4. So which is basically, we give you something like 148. If you are with me, please go ahead and take out your little calculator, whatever you have, and make sure we get the right number. And we're gonna do it again. 128 plus 16 plus 4. So it's 148. So it looks like we are on 1 point. So this number you see at the top here, this binary number you see 10010100 is equivalent to 148. And how will you know that? So as you can see, so let's just say we really want to convert this same number. We are going to use the same logic, and I'm going to erase this. And now let's just say for any kind of, we just have a random or decimal number that we have right now. We want to convert that number into a binary. So basically what you do here, as you can see, we already have 128, 16, and 4. So let's just say we already have this table in front of us. So we have this number over here. Right now, there is no way, of course, we can remember that. So binary number, we don't have it down. We don't write it down. We already erase it completely. But we have some information here, very important, which is 128 here, 16, and then 4. As long as we have those, they are equivalent to 148, right? So now if we want to get a binary number equivalent to that, so the same number that we get before, of course you guys have it, but I don't have it anymore. So you guys make sure and take note and see what we're going to do. So we go back to our table starting from 128 to 4. So now if we are looking to get this number, can we consider 128? Yes, definitely we'll consider 128. We put here 1. So let's go back here and put 1. And then if we are looking for 148, rather 148, maybe I call it 128 before, but please sorry about that. So if we're looking for 148, do we need 128? Yes, we do. We do need 128, so we write 1. And then if we are looking for 148, do we need 64? No, we don't need 64, because if we add 64 and 128 together, hopefully you're going to have a number higher or greater than 148. So you write 0. And then if we are looking for 148, do we need 32? So if you add all those together, or maybe you add 128 and 32 together, you are going to have a number higher than 148. So you again write 0. So if we are looking for 148, do we need 16? Yes. Why you need 16 is because if you add already the one that you turned on, if you add 16 to it, it is still going to be less than 148. So you need that number. So we're going to turn 16 on. So if you are looking for 148, do you actually need 8? No, you don't need 8, because as you can see, if you come down here, you will see 128, 16, and 4. These are the only one we need. But I'm taking this time just for you guys to see how you'll be playing around with the logic besides this number. And basically for this one, after we're done with this one, we are going to take a totally different number. We're going to take a totally, maybe just a smaller number. I just need you guys to understand, it's not something, it's the logic that matters. It's not even about what kind of numbers you play around. It doesn't matter how big the number is. If you use this logic, it's really easy. So now, do we need 16? Yes, of course we need 16, but do we need 8? We can see 8 here, so we write 0. And then do we need 4? Of course, we need 4. Do we need 2? No, we don't need 2. And do we need 1? No, we don't need 1. So if you compare that first number, binary number we have, that will give us equivalent to 148, is the same as this one. So there is no difference. This is how you play around with this binary system. But now, let's go and pick something completely different. So I'm going to go ahead and erase this table up first. And let's take a number completely different, which is basically we are going to take a very small number. And then when we're done, we're going to prove ourselves right. So let's take a number. Hopefully I will take it from my subscribers, or you guys can suggest any number. But right now, I will definitely go ahead and take the challenge, and then we do it together, not me alone. And so let's just go ahead, patient, bear with me. Let me just erase this and make it a little bit cleaner for you guys. So as you can see, we get everything fine. So let's take a number. Let's just say go ahead and take 20. Let's go ahead and take 20. So we actually need 20 to know the binary number of 20. So what is it? We don't know what it is. We don't know what it is. And so we are going to use the same logic slide to get a binary number of 20. So in the same way as I was talking, without wasting time, do we need 128 if we are looking for 20? No, because 128 is way higher than 20, so you put 0. Do we need 64? No. So you put 0, you write 0 there. Do we need 32? Definitely not. 32 is still greater than 20. You write 0. So do we need 16? Yes, now 16 is less than 20. So now we're going to get our first one here. So we turn that one on. So looking for 20. So now as long as we get one, so the next one that you will be getting, you have to think about adding them that will give you exactly 20. You are not going to look for a number that is going to go above 20. So let's just say if we consider 8 right now, 8 and 16 will give us above 20, which is going to be 24. So we don't need that, so we write 0. So looking for 20, if we add up 16 and 4 together, can we get 20? That's right. So we turn right there, we turn 4 on and looking for 20. And of course, we already have 20, so we cannot go beyond 20. So everything that remains is going to be 0. That's all we did. So as you can see, we have 0, 0, 0, 1, 0, 1, 0, 0 is equivalent to 20 in binary. So if you don't believe that, go and take any calculator and go through it and see what you are going to get is basically going to be the same as what we have here. So this is how you play around with the logic. But if you have any questions, guys, any number, anything you're thinking about, so that will take you very less time, use this logic to make this work out. There is no point of you going ahead and memorizing this. So this is all how it works out. So now we have 20 into the binary number, and this is what we get. So now we're going to take our last example, but before doing that, let's go ahead and make our board a little bit nicer, and that way we get everything nice. Bear with me. This is a brand new channel, so we have a lot of stuff to improve, but definitely what matters is the information. As long as the information is right, that's all matters. You're making use of the information. It's making your job easy. And so I am going to look among my subscribers. I will take any random number that they suggest to me. So what we're going to do, let's take a number 55 right now. So this number 55 is a human readable number, so we can be able to convert this number, or basically we can be able to make use of this number. But then computers have no use of this number because we have to change this number into binary format for them to use it. So without wasting time, we use the same logic using the table, using from 128 all the way to 1. So if we are looking to get a number of 55, are we considering 128? So definitely no, because 128 is way too higher than 55. So we write 0. So if we are looking to get 55, are we going to consider 64? No, 64 is way too higher. So we write 0. So if we are looking for 55, are we going to consider 32? Yes, I think 32 is less than 55. So this is where you start to get your first bit on. So we write 1. So if you are looking for 55 and then you already have 32, so basically, are you going to consider 16? Think about it. Definitely yes. So because if you add 16 and 32 together, that will definitely give you something like 48. So meaning you are getting closer to 55. So we need that because we are looking for every single number that can get us closer to 55. That's all we need. And so now we have almost like 48. Go ahead and add that up for me, please. And so now that we have 48, so if we're looking for a number that will give us 55, are we going to consider number 8? No, we will not consider number 8, because if we add 48 and 8 together, we give you something. For if you have 32, 16, and 8 all together, that will give you something like 56. So we don't need that, so we put 0, we write 0. And if we are looking for, we already have 2 ones for, which is basically we have like 48. If we are looking for a number that will give us 55, are we going to consider number 4? So definitely I would say yes, because it will still be less than 55. So if we consider that we have something like 52 already, and so if we are looking for a number that we get us to 55, exactly, are we going to consider number 2? Because right now we already have something like 52. So you say yes, and that will get you onto 54. If we are looking for a number that will get us very closer or even exactly to 55, do we consider 1? Yes, because we already have 54. So if we consider 1, that is going to be exactly 55. So we have our binary number using that same logic I have shown you guys. So now let's go ahead. We have our binary number nice and clean. So let's go ahead and read it. 00110111. That is basically 55 in decimal value, and that is the number in binary value equivalent we have just converted. And so this is how you play with these things. There is no other logics. But as I promise you, my next video is going to come out about decimal values or to hexadecimal, and then our binary to hexadecimal and vice versa. So right now it's just the beginning. This is just like for you, basically for you guys to get confidence and see how simple it is. If we get into hexadecimal, that most people even complain, they complain about it, it's too hard, you have to memorize some numbers. No, I will still give you the confidence. Do not memorize anything of such. When we reach to that point, you will thank me for whatever reason, maybe when you get the concept. So don't think about it, nothing about it. So for this video so far, we are going to stop from here. I hope whatever examples I have done here, and for give you a final challenge when we come into our next video, I will actually love you guys to give me a binary value of 120. This is for my subscribers. Just go ahead and change this number using the same logic. Don't use another logic. Don't use a calculator. I mean, you can use a calculator to make sure you add your numbers together, but do not use any calculator that will convert to give you the binary values. You have to use this logic and see how it is easy. So I need you to come up with 120, and then basically do me a favor and come up with 99. Come up with 99 binary value of 99. So I only give you like 2 assignments today, which is 120 and 99. So I started with a higher number, and then down below is 99. So when we come into our next session, I will put up this topic up for you so that you guys can stick around. So today we do our decimal system or to binary. So we see here binary numbers to decimal system. So we leave the hexadecimal out, because when you are confident converting binary to decimal and then going back and forth, this is really something that will be so easy for you to know the hexadecimal system. So our next video will be on purely mastering the hexadecimal system to binary, for binary to decimal system, and then we do it vice versa. But so far so good. I really appreciate you guys coming around, and our next video will be on hexadecimal system. Thank you so much for coming today, and if you really find this information very useful, please go ahead and subscribe to my channel, and then I will get you more information that is valuable to you and easy to use for your daily life, for your job, for your school, or whatever information you need it for. It will be really valuable and easy for you. Thank you so much. Go ahead and subscribe, click the like button, and I will see you in my next video. Thank you so much.